Free college, sum and product of roots. What are the sum and product of the roots of the equation 3x squared minus 7x plus 12 equals 0? To find the sum and product of a quadratic equation, you have really two options. The long and unnecessary option is to go through the whole quadratic formula. I mean, if it's factorable, you could factor it, but if it's not, you got to do the quadratic formula. And even if it's factorable, you could still do the quadratic formula to find the roots, and then once you have the two roots, you can add them together to get the sum and multiply them together to get the product. Or you could just use a very quick and short formula that the sum of the roots can be found as negative b over a, and the product of the roots, fix that, the product of the roots is c over a. Remembering that we have three numbers in here. The coefficient of x squared is a, the coefficient of x to the first is b, and the constant on the end is c. And so there's your a, b, and c. So for the sum of the roots, negative b over a. So my sum of negative b over a. Now remember, negative b is just like in the quadratic formula. It doesn't necessarily mean the number is going to end up being negative. It just means kind of like opposite sign, the negation of b. So in this case, my b is negative 7. So negative b is negative negative 7, which is positive 7. So it's like opposite sign of b over a is 3. So my sum is 7 over 3. And I see that here and here. It's not negative 7 over 3. It's not 7. The product, c over a, is simply 12 over 3, but that can be reduced down to 4. And so the answer is c. So negative b over a, c over a. If one root of the equation x squared plus kx minus 15 equals 0 is a negative 3, what is the other? Sometimes you'll see these questions where it says one root. It could say solution, or it could call it a 0. We have a couple different names for that, but in this case we're calling it a root. So one of the roots, one of the solutions to this is negative 3. And they want to know what is the other. And so what you want to use here is you want to use the sum and product. Now the sum is negative b over a. In this case, that would be negative k, this is acting as the b term, which we're missing, over 1. And that's not really helpful. But the product of the roots would be negative 15, which is our c, over 1. And this is useful because the product of the roots is negative 15. That means my two roots multiply to negative 15. So if one of them is negative 3, the other would have to be positive 5. This way, their product is negative 15. And then product just means multiplication. If I know what one of them is and I know what they multiply to, I can figure out what the other one is. And that's simply the answer here. A lot of times, though, they ask you to actually find k in this scenario. So I know the problem's not asking for it, but let's do that. And again, the way to do that is, now that we know the two roots, I can figure out their sum, because their sum is simply adding them together. Negative 3 plus 5 is 2. So if I know the sum is 2 over 1, and that corresponds to negative k over 1, that means that negative k equals 2, and k equals negative 2. And so you can kind of back solve it a little bit. Or you can, kind of work backwards with these being roots and find out the whole equation, and I'm going to get into that in the next problem. But that's how you want to go about this if you have a missing values. Even if you're missing b, you still have your c over a for product. And say I'm missing c, but I have a and b, well then I know what the sum is, and so you can figure out what the missing root is. So write a quadratic equation from the sum and the product. So the sum of the roots is 6. The product of the roots is negative 27. I do not know what the actual roots are. Could probably figure it out, but I don't need to right now, because along with our negative b over a and c over a formula for sum and product, we have another formula that we can use in this concept, and it goes y equals x squared minus the sum of the roots x plus the product of the roots. Just like that. So if you have the sum and product, you can simply plug them into this. So my equation would be y equals x squared. My sum is 6, so it's minus the sum, so it's minus 6x. And then plus the product. My product's negative 27. So plus negative 27, we're going to write it's just negative 27. So remember, the sum has the opposite sign from what you see here to here. The product keeps its sign from what you see here to here. And that's basically it. So this is a very useful formula. Now, if these were fractions, I could multiply out the denominator, and that's how I'll end up with something in front of x squared. And maybe we'll see that in class. But definitely write this formula down. It's just as useful as these are. So x squared minus the sum x plus the product, negative b over a, c over a. That's the key to this whole topic. All right, this time we're given the roots. Write a quadratic equation with roots of 2 minus 3i, and 2 minus rad 3, and 2 plus radical 3. So these are irrational roots. They would come from the quadratic formula, and I want the equation. And so I'm not going to do the quadratic formula backwards or anything like that. That would be kind of crazy. What I'm going to do is I'm going to use what I just said, was I could do x squared minus the sum x plus the product. So all I need to do is find the sum of the roots, which means add them together, and the product of the roots, which means multiply them. So let me first do the sum. The sum of the roots is adding 2 minus rad 3 plus 2 plus radical 3. And that's actually really easy because your minus rad 3 and your plus rad 3 are additive inverses and they cancel out. So it's really just 2 plus 2 is 4. And this will always happen when your roots are complex like this, because it comes from the plus or minus in the quadratic formula, that whether it's I or radical, adding them together is really easy. It always ends up just kind of being the first numbers added together. So the sum is no problem. So we know this part is going to be x squared minus 4x, because it's opposite sign of that. And the product is a little bit more complicated because it's multiplication, but it's really not too bad, because when you have complex roots like this, as I was saying, they come in pairs of conjugates. So you're multiplying conjugates. And that was something that we've talked about in a couple of different topics, conjugates, that when you multiply conjugates, you don't need to do all of FOIL because your middle terms will cancel out. So really you just need to multiply the two first terms. 2 times 2 is 4. And the two last terms, negative rad 3, positive rad 3, is negative 3. And so 4 minus 3 is 1. So my sum is 4, my product is 1. So x squared minus the sum would be x squared minus 4x plus the product is 1. That's it. Let's do one more example like that. This time, one root of the quadratic equation is 5 plus 5. What is the other root? All right, well, the other root, as I said, these complex roots come in conjugal pairs. So the conjugate of 5 plus I is 5 minus I. And that's actually the answer to this question. So that really wasn't much to that. All right, so what you'll see in the questions we do in class tomorrow are similar. Just a quick recap that to find the sum and product, just use negative b over a for sum, c over a for product. You can use that to find a missing root or find a missing term like k in the equation, the concept of negative b over a and c over a. If you have the sum and product, you could get the equation really easily by doing x squared minus the sum x plus the product. If you have two complicated roots, you can sum them to get the sum and multiply them to get the product, and then use that equation, x squared minus the sum x plus the product. And if you only have one complex root, well, the other is its conjugate, so it's easy enough to find. Okay, see ya.